So my name is David Soderman. I'm an air pollution chemist working with San Diego. And today we're going to talk about building a bigger, better zero error generator certification process. So why even have one? As it turns out, EPA has put in a rule in the QA handbook that the station zero error generators need to be certified annually. As well as the NAC standards are lowering and lowering, our audits and calibration points are decreasing in concentrations as well. And at these lower concentrations, if your zero error generator is just, say, slightly high by 1 ppb relative to, say, ARB's or EPA's zero error generator, this percent error is starting to propagate up higher and higher, especially on these lower points. So what is the ideal certification procedure? Well, first, we're going to determine the instrument's response from, say, a certified zero error cylinder. Then we're going to determine, is the instrument measuring below the lower detection limit? If the answer is yes, that's great. Then we can go on and compare the instrument's response to the zero error generator. If the answer is no, because this is a certified zero error cylinder, we know that this elevated zero is really just due to probably a calibration error, calibrating a little high, or maybe the instrument drifted. So now you can just adjust the background coefficients or the zero coefficients, and then directly move on to determine the response from the zero error generator. Now, when you do that, you can now ask yourself, is the response from the zero error generator, is that less than the lower detection limit? The answer is yes. Then you know that your zero error generator is certified to be clean and you can move on. If the answer is no, then you need to maybe make some modification to your zero error generator. Maybe the scrubbers need to be changed. Maybe the zero error generator is just not up to spec. Maybe you have an older version. Maybe you need to buy a new one. So what's the problem with the ideal procedure? That'd be great if it worked. There's lots of zero error generator or zero error cylinder vendors out there that you can buy gas from. The problem is those vendors' certified levels aren't low enough with the new instrumentations, with the exception of CO. And this table here below kind of illustrates that point. So San Diego decided, you know what, we're going to get rid of the cylinder and we're going to kind of come up with our own procedure. And our own procedure is we're going to take the best available zero error generator that's on the market, and we're going to connect that to a clean sampling manifold that's only used in this certification process. We're going to analyze the output from this, what we now are going to call a reference zero error generator. We're then going to disconnect that and connect up our station zero error generator and analyze the instrument's response to that. Then what we're going to do is take the output of the station zero error generator and run it through an external scrubber system to see if just running it through additional scrubbers will lower the concentrations. And so how did we come up with what was the best available technology? This is just a little table here of different instruments. You got the cylinder there from Scott Marin, based in Riverside. You also have 3 manufacturers there. And the one that we decided to go to was the Teledyne API 701H. This is the diagram of what's inside of it. You can see it's got a pump, it's got lots of different scrubbers and systems there. And one of the things that we wanted to do when we looked at what is for our external scrubber system, we wanted something that was really simple. We wanted something that's portable. We don't want to have, if we have 9, 10 stations, we didn't want to have 10 of these. We wanted to have one of them. So we wanted to have something that was easily portable. We also wanted something that we don't have to be super cautious with it of, say, using a hydrocarbon scrubber that has to heat up to 300 degrees C. So we wanted something very simple. So what we did was we took all the scrubbers out of the 701H that didn't need any electricity, and we just mounted that onto a board. So here's our setup of our procedure. So, and here what we do is we can connect either the station or the reference zero generator to a valve to kind of throttle back to give us just the amount of flow that we needed, to an 8-port glass manifold that we connect our instruments to. And this particular site has NOx, CO, SO2, and ozone. We plug the other ports except for one last one, which we connect up to a rotometer, and we measure the excess flow there. Now, the reason we measure the excess flow there instead of just putting our hand there and feeling, oh yeah, we got excess flow, is that there is such a thing as too much excess flow. If you have too much excess flow, you end up building up the pressure in the glass manifold, and that affects your ozone instrument tremendously. So you get if you have a real high flow in there, you'll end up getting a really big negative spike on your ozone. And we've seen it down to negative 10 ppb. And it takes about an hour before it reaches zero again. So you definitely want to make sure that you don't overpressurize that cell. Here's what our external scrubber system looks like. You have the zero generator, go through a valve, go through some scrubbers, go again to that glass manifold there, again measuring the excess flow. This is what it looks like in real life, kind of missing a valve there. And what we can do here is, if I get the mouse working, is right up here is where we can connect the valve and connect the zero generator there. The other thing is when we aren't going through the scrubbers, there's a valve that sits in this block here, and we connect it up here, and then just goes straight here in here. So the other thing that we decided to do is to ensure that our reference zero generator is running optimally, is we decided to change out the scrubbers on a pretty quickly basis. So in reading the manual on the 701H, it tells you that you should change out the pure-fill and the activated charcoal on a yearly basis. So we're going to do that for the station as well as the reference zero generator. The CO catalyst, the molecular sieve, they pretty much said that those are good for the life of the instrument, but they can become poisoned, and so to change those out periodically. On our reference one, we're going to change those out yearly. On our station ones, we're going to change those out every 2 years. And the external scrubber system, since it's only used for a short period of time, only a few times during the year, we're going to basically take the ambient station schedule and just double that. The other thing we did was we developed a QA/QC criteria for what constitute a pass and what constitute a fail. And one of the things we wanted to address is that when we measure the value of the reference or the instrument's response from the reference or the station, is that value needs to take into account instrument drift. Maybe you calibrate, maybe you got an older ozone instrument and you can't get a perfect zero, so you calibrate it, with the zero being 1 or 2 ppb. And so we want to take into account instrument drift. So what we did was, for the zero generator certification, is that we took our as-is calibration limits. For ozone and NOx, that's plus minus 5 ppb, and for CO, that's plus minus 0.6. Now, this takes into account our final calibration zero limit tolerance, as well as the EPA 24-hour drift requirement, which is plus minus 3 ppb for ozone and NOx, and 0.4 ppm for CO. The other thing we wanted to do is, if we measure the reference zero generator, we measure the station, the difference between that needs to be within a certain amount. And that needs to take into account the instrument noise. So everybody knows that when you measure zero on an instrument, it doesn't read just zero. It bounces up and down. So we need to take into account the instrument noise of it. And what we did was we took 3 times the RMS noise. And the RMS noise of each instrument is a manufacturer's specification. So we felt 3 times that would give us a good idea of that there is a real difference between the 2 zero generators. The other thing is we wanted to know is if we took that station zero generator and ran it through additional scrubbers, if that value dropped significantly, then that indicates that that station zero generator needs either servicing, maintenance, replacement. So what is that? Well, that again, what that value, it needs to take into account instrument noise. And again, we chose 3 times the RMS noise. So this is just going to be a flow chart that kind of goes through those criteria and how we determine if it passes or fails. So the first thing we do is we're going to run the reference zero generator, get the instrument's response to that. Now, then we're going to look at those values. Is that value less than or equal to our as-is calibration limits? If the answer is no, then there's something already wrong. And it's, you need to address that issue, investigate it, maybe issue a corrective action notification, resolve the issue, and then you can start over. Let's say that the reference value is less than that, less than the cal limits, and the station is less than the cal limits. Okay, so now we look at the difference, the station, the response from the station zero generator minus the reference zero generator. Is that less than negative 3 times the noise? If that difference, the station minus the reference, is less than negative 3 times, what that indicates is that the station value is much less than the reference value. Well, we've already decided that the reference ones are best one in the network. So how can we have a station one that's less than that? Well, that indicates that there's something wrong. And this could be that your reference zero generator needs its scrubber changed. Maybe it got contaminated in there. So replace it, fix it, start over. Let's say that it's greater than 3 times the noise. What this means is that the response due to the reference zero generator is much less than the station. So the station's reading significantly higher. So what this indicates that is that if you had an identical reference instrument as a station one, you would get better zeros. If it is the same model number, then most likely it means that you need to change out your scrubbers. So let's say it's in between. It's in between plus minus 3%. Now we can move on to the next step. And the next step is looking at the response of the instruments when they measure the station zero generator versus when they measure the stationary generator coupled with this external scrubber system. Let's say it's less than negative 3 times the RMS noise again. So what this indicates is that the station response, or the response of the instrument when measuring just the station zero generator, is significantly better, significantly lower than when it's measuring it through the same station zero generator, but coupled with an external scrubber system. So if you scrub it more, it should be lower. So how can it be higher? Well, this indicates either maybe you have a leak in your external scrubber system, maybe they're poisoned, maybe they're contaminating. So this needs to be resolved, and again, start over. Let's say it's greater than 3 times the noise. Then this indicates that if you're scrubbing it more, you get lower numbers. So what this indicates is that most likely you're probably going to have to change out the scrubbers in your station zero generator. And if it's, this is a typo here, this really should be plus or minus 3 times the noise. If it's between plus or minus 3 times the noise, then there's really, the difference that you see is not significant, and you're good. You got a good zero generator. You can move on. So now let's look at the first 14 tests that we did. Now, the first 3, we were really trying to figure out what the heck we were doing. And if we look here at this blue reference line, you can see that for the station and the reference, as well as the station with the external scrubber on the top graph here, that you can see that it all falls within our plus or minus 5 ppb. So those tests passed. So now we can look at the differences. So we'll look at these first 3 here in the blue. You can see here that the station zero generator is too high compared to the reference zero generator. And you can also kind of see that if you look up at the top graph there, that the reference is measuring close to 0, whereas the station is about 1.6 or so, 1.6, 1.7, so a little high. So this indicates that the station zero generator is not performing as well as the reference. In this particular case, this is two different model numbers. The reference is a 701H and the station's a 701. So it's the older version. So this indicates that if we just upgraded our zero generator, we would actually get better numbers, better zeros. If we look at the difference between the station versus if we scrub it versus not scrubbing it, we can also see that it also fails our criteria of the 3 times the noise. And so this indicates that we need to change out the scrubbers in our station. So let's look at NO. NO, you can see here, is very boring. Pretty much all 3 things, or all 3 responses pretty much are all the same. They pass plus or minus 5. They pass plus or minus 3 times the noise. So very boring. So we're gonna move on. So now we get to NO2. You can see here that our absolute plus or minus 5 criteria, it all passes. We get one test here, test number 11 for the station. It's a little high, but just based on this, it still passes. But when we look at the difference, we can see here that it fails. That comparing the reference response versus the station response, we get a much better response from the reference zero generator than the station. And if we also look at it, if we take that station and we scrub it more, it drops tremendously. I know it almost is the same as the reference. So you can see here that this station scrubber probably hadn't been changed. Now, what's the cause of this? Well, before we all started this, we had our site operators change out the scrubbers on our zero generator once a year. But we really didn't enforce it. It had to be the same month every year. So, and our site operators change stations every year, get them rotate. So some sites have more equipment than other sites. So instead of penalizing one person because he's got the NCORE site, and one guy's just got just the ozone site, they get rotated around. So it's really up to each operator to look and see of when was the last time it got changed. And sometimes things get busy, special projects happen, and it might go 15, 16, 17 months before the scrubbers get changed. And that's probably what happened here. If we look at CO is very similar to NO, very boring, everything passes, which I guess is a good thing, but not for presentation purposes. So summary and recommendations. Lower QA levels are requiring lower QC levels. Newer technology instruments are making it harder and harder to use the zero air cylinders as your reference source. So to truly test whether your station zero generator is performing and giving you good numbers, you really need to use another zero generator. Back at that slide that had all the different manufacturers, pretty much all the new zero generators, no matter what manufacturer you have, is going to give you better numbers than a zero cylinder. And our recommendation is to conduct a certification in a dedicated manifold. That way you don't have to worry about having to clean it to prevent contamination and bias. And really try not to overpressurize it. If you overpressurize, your ozone's going to go really, really negative, and it's going to take a long time. So what we typically do is we run at least for 30 minutes and then take a 10-minute average. But if you overpressurize it, it might take an hour or over an hour. And some of our early tests, we probably did overpressurize it because we weren't measuring our excess flow. And that's probably why, if we look back, we'll go back real quick to ozone. On this third test, you look at our reference one, we're getting about negative 1.5. That probably isn't real. But when we were doing this, we ran for 30, 40 minutes, and we got 10 minutes where it was sitting at negative 1.5, or negative 1, negative 2. So, but if we waited maybe another 10, 20 minutes, maybe it would have been closer to 0. So really don't overpressurize Don't overpressurize it. We found about 2 or 3 liters per minute of excess is good. And just as a disclaimer, this is something we worked on. We sent our SOP that pretty much encompasses this whole presentation up to EPA. We haven't heard anything good or bad or indifferent from them, but they are aware that we're doing this. And with that, I think we have maybe time for a couple questions. Yes, we got one in the back.
I was just curious for auditing groups like the ARB or EPA, if there's a certification process for their zero error supply used during audits.
When they come and audit us, they haven't done a certification process on our zeros. I mean, when they do, like say ozone, they'll do a zero before and after, and they do have criteria on what those zeros should be, but they're not looking at a certification process on that.
Right now, the way we certify it is our zero error system is checked using an ultra-pure cylinder. Knowing what we know about those cylinders, we are going to have to develop a system to check our system in addition to what we currently do.
Any other questions? Yes, Carl.
Yeah. We're being recorded. So, as you pointed out, ultra pure air is not pure enough with these trace contaminants. Did you look into, ultra pure nitrogen or maybe a mixture of nitrogen and argon if you want to get the same density as air or something like that?
We contact Scott Marin and asked him, we looked at your ultra pure zero air, and those specs were too high. And I asked him, I said, well, what if you blended a synthetic air of taking ultra pure nitrogen and blending it with ultra pure oxygen to give you, 80%, 20%. And he said, yeah, it should be lower, but I can't prove it. I can't certify it. So it's going to have the same certification levels as the ultra pure air cylinders.
This was a finding for ARB and the TSA. Unfortunately, we had so many findings, we had to prioritize the ones that we tick off. And that is one that is on our to-do list for ARB's systems.
We have time for one more? Two more?
When you're measuring the 2 to 3 liters of excess flow, do you have an idea of how much pressure is actually in the manifold as far as like half an inch of water? Or
No,
couple
that's
tenths?
something that we thought about adding on a pressure gauge, like a magnet helix. I mean, that's something that's really inexpensive. You got 8 ports there, so unless you're, doing 2 or 3 ozones, 2 or 3 NOx, you should definitely have an excess port on there. That's something that we thought about adding on there to see what is the pressure in there, but that's not something that we've done at this time, but it might be a good idea.
Is it fair to conclude you said that the 2 to 3 liters is your bypass from the manifold? Is that right?
That's correct.
Okay, and I may have missed this, but your instrument for determining the LDL, which one was that?
For
the zero error to verify zero error.
it's like if you're at a station that has ozone and NOx, it's for each one.
Okay.
So but that's more of the ideal procedure, and we're not following the ideal procedure because it can't be done because you don't have the certified values, and because you have instrument drift. When you measure a pure zero, it might be above your LDL because of instrument drift, and we're not trying to say, hey, this instrument has to be less than the LDL at all times. We're allowed to have some sort of instrument drift, and so we're looking at it like at this snapshot. What is it?
Wouldn't that 2 to 3 liters also depend on like the diameter of your vent port?
It could, if you restrict it down.
Pressure would be a much
Yeah,
better
yeah,
indicator.
pressure probably would.
Great questions and great presentations. Let's give them a round of applause.
Thank you.